Today we'll be doing lesson 25, the difference of two squares and oriental squares. So let's look at our first example. It is going to be, how do we factor x squared minus 9? So that's what we have right here. We see 9 squares and no x term here. So how are we going to factor this? Well, we know that we're going to be looking for something where this will make a rectangle. And I know that I'm going to have some rectangles I'm going to have to be adding here. So first I'm just going to arrange this. I have a nice little square here. And let's see, that would be 3 across here and 3 across here. If these 3 are positive, and then I add 3 that are negative, then that will give me a zero pairs, right? So 3 positive and 3 negative makes 0 altogether. If I put them in here like this, does that make sense? Well, let's see, our factors would then be a positive x, because we have a positive x squared here, so 2 positive x's. And this one would need to have positives across the top, because we have positive times a positive makes positive. And then this one down here, these would need to be negative. And that would mean that a positive times a negative would be a negative, and positive times negatives would be negatives. When we look at this, these are our factors. I just laid them out, so we don't include these outside of the pink with our inside answer. So our factors would be x plus 3, that's the one across the top, and then the one across the side is x minus 3. And then it makes sense when I multiply it. I have this x squared. I have the minus 9, because right here I'm going to have minus 3 times a plus 3. So that's my last term. So my first term is my x squared. My last term is going to be that minus 9. And then on the inside, or outside, the outside would be a minus 3x, and the inside would be a plus 3x. And those will add up to 0. And we're left with just the x squared minus 9. So that's what today's lesson, the difference of two squares. Why do I call it the difference? Because we're subtracting, and subtracting is the difference. Notice that both the x squared and the 9 are perfect squares. That minus sign in the middle is difference, so that's how we get the name, the difference of two squares. Let's try a second one. X squared minus 25. So when you start to see these that don't have a term for x, think about it and say, is this a perfect square? Is this one a perfect square? Do I have a minus sign, that difference in between? If so, then I will probably be looking at the difference of two squares. So I just take the square root of x squared, and I take the square root of 25, and then one of them will be plus and one of them will be minus. And the reason is that the outside and the inside terms, when this is the same numbers, but one is minus and one is plus, the outside and the inside terms will end up being a positive and a negative, and they will cancel out or add up to 0. So our third example, we have x to the 4th minus 4. This isn't x squared, but it is still a perfect square. And this is a perfect square, and I do have a minus in between. So I'm going to take the square root of x to the 4th and get x squared, and then plus 2, and an x squared minus 2. Because remember, one's plus and one's minus, so that when I multiply that outside and the inside term, I have a negative one and a positive one, and that will add up to 0. At this point, this one isn't quite a perfect square, because 2 is not a perfect square, so I cannot factor this again. Sometimes, though, you will find that you can factor it again. So remember that this is the difference of two squares. If I have x to the fourth plus 4, I cannot factor it this way because that plus 4 means that the signs on both of the factors would have to be the same, and that means that the outside and the inside term will not cancel out to 0. So you cannot factor a plus with two squares. So I feel like this lesson is fairly straightforward. You're just looking for each of these being squares. Each of these are squares, each of these are squares, and there's a minus sign in between. You're going to factor by having the same numbers with one as a plus sign and one as a minus sign. We can use this for other things. So a trick for multiplying squares that end in 5. In other words, two things multiply together. 15 times 15. These end in 5, and I'm multiplying the same numbers together. I could do something like 35 times 35. They both end in 5. It's the same number, so it's a square. So if I draw what 15 by 15 would look like, I'm going to kind of cut off the 10 by 10, right? And so I have this as a 10 by 10, which is 100. This is 5, and this is 5. So the 5 times 5 is 25. This is 10 long, but 5 across. So this is 50. And this is 10 by 5. So this is 50. Really, I could kind of think about taking this part right here and moving it right down here. So now I'm going to take this off. And if I move it down here, it's just another 50. I've made this now a 10, and this is a 10. So I have two sets of 10, or 20 times 10 plus 25. Let's see if it works the same way on 35. I'm going to have to draw a little bit bigger square. See if I can make it somewhat reasonable here. So if this was originally 35 by 35, on the inside, when I kind of cut it down, I'm going to have a 30 by a 30. And then I'm going to have a 5 by a 5. So this 5 by 5 is a 25. And this one I'm going to take, and I'm going to take this one, and I'm going to move it down here. So now I have 5 and 5, or I have 10. So now I have 30 by 40 if I connect all these together. So 30 times 40 is 1200, and then 25. So do you see this kind of trick? I'm just moving this group of 5 down here so that I can make them whole 10s, but then I always have this extra 25 that came out because that 5 by 5 was there. So the trick to multiplying squares that end in 5 would be to kind of rotate that 5 around. So what I do is I say, I'm going to round this, kind of rounding this one up and rounding this one down. But remember, we're taking the 5 that was over here and just bringing it down here. So we had 30 times 40, and then we're going to have to add the 5 times 5, which was 25. So this would be 1200 plus 25, or 1225. What if I wanted to do 75 times 75? Well, remember, I have 70 and a little 5, and I have 70 and a little 5, and I'm going to take this little 5 and I'm going to move it so that I can put it down here. I'll still have this box of 25 hanging out by itself. This will now be 80. And so I will have 70 across the top times 80 down the bottom plus that little square of 25. So 70 times 80 is 5,600 plus 25, so 5,625. And hopefully you'll find that this is a little bit faster if I remember how to think about it and how to move it around a little in my head. This is going to be faster than if I were to write out 75 times 75, and I do 5 times 5 is 25. 5 times 7 is 35, plus 2 more is 37. I carry my 0. This is 35, and now I have 7 times 7 is 49, plus 3 is 52, and I add them all together, and I carry the 1, and I get 56.25. So I got the same thing, but this was just a little faster in my head. Even on paper, writing it down, this was faster to me than doing it this way. So it's just a trick for playing with numbers and doing specific numbers a little bit faster. So it's not required. You can still do the long multiplication, but I think it's just a really cool trick to think about. And then we may even use the difference of two squares. So how would we figure out 27 times 23? Let's see. What if I think about 27 as 25 plus 2? And I think about 23 as 25 minus 2. Are you seeing any pattern here that we just did that could maybe apply? Remember, when we factored something like x squared minus 9, we said it was x plus 3 and x minus 3. So do you see this number here plus the same number, plus 2, and then this first same number minus the second same number? So when we multiply this together, we can leave out the outside and the inside terms because they cancel each other, and we just have to multiply the first and the last terms. So the x squared, and then it's a minus, and 3 times 3 is 9. So we square the first term, we square the last term, and that's what we get. So right here, this problem would be squaring the 25 and squaring the 2 and subtracting. Now, 2 we know how to do. 2 squared is 4. And then 25 squared. Well, you might think, well, this isn't really any longer. I might as well just multiply it out. Or what did we just learn about moving that 5 piece down? So making it 20 times 30 with that extra little 5 by 5 or 25. So 20 times 30 is 600 plus 25 or 625. Now we just subtract 4 and we say that the answer is 621. And we didn't have to multiply this out in long multiplication. Now you might think these are a few more steps than if I had just written it out, but I think after a while you can get to where a lot of these are in your head. Maybe you just write down this step and then this one and you get to your answer. And then that writing would be the same as if you were writing the long multiplication steps. So what this really looks like are our difference of two squares. The traditional way of writing it and showing that it can be anything, not just x's and numbers, but a squared minus b squared is a plus b times a minus b. And so now we're just applying this to numbers instead of just variables. If we did 48 times 42, I look and I say, well, this is 3 away from 45, and this is 3 away from 45. So 45 plus 3 and 45 minus 3. Now that looks a lot like this, so all I have to do is square 45 and then square 3 and subtract it. 3 squared is 9. 45 squared. Okay, I'm doing that one in my head a little bit. I'm saying 40 times 50. That's a 20 with 2 more zeros plus the 25, that little extra little square that I had. So 2025 minus 9, and that would be 2016. So the Oriental squares plus the difference of squares method works when the tens place is the same. This is 40 and this is 40. And then if we can add these two numbers up to 10, that means that they're going to be on either side of 5. So 45 plus 3 and 45 minus 3. The last one we did was 27 times 23. And the 7 and the 3 add up to 10, but that's because this was 25 plus 2, and this was 25 minus 2. So if our tens place is the same, and our ones place adds up to 10, tens place is the same number, our ones place adds up to 10, then we can use this difference of two squares and our squaring the number ending in 5.